Okay guys, so this is video number two. Video number two on solving radical equations and inequalities. Video one that we did yesterday was on solving radical equations, and today is more on solving radical inequalities. However, I do want to mention what I'm doing here is I'm getting the book, we're going over the examples and understanding how they do it, because ultimately this is how you guys are going to learn math in college, right? It's not going to really be about the professor or the teacher explaining things. I mean, you'll get something out of that, but mainly you're going to be learning by getting the textbook, looking at the examples and the explanations that they give on the examples, so you could actually learn what's on that section. So moving on to this page 429, we already did this yesterday. We learned how to solve radical equations. And we realize that it's very, very, very important, it's essential that you check your answer once you solve it. Like down here, we got an answer of 16, and when we check it, it doesn't work. When it doesn't work, that means it's an extra answer, so we call it an extraneous solution. Again, that's an extra answer that does not actually work, extraneous solution. So technically, if you only get x equals 16, and it doesn't work, it's an extraneous solution, then you would say that there is no solution. Okay? No real solution, that is. Now let's turn the page and let's look at other examples. Let's jump to example number 2. This is also a radical equation, even though you don't see a radical right there. But we do have a rational exponent, the power of 1/3. And what is the power of 1/3 really? The cube root, right? The third root. So in reality, this is really a 2/3 root of 6x minus 3 minus 4 equals 0. But you know what? We don't even have to look at it as a radical. We could keep it as a rational exponent. Let's keep it as a rational exponent. And actually, they keep it as a rational exponent. Let's just follow along on how they work this out. And of course, the explanation's right here on the side, but I'm doing that for you. First, you want to isolate the rational exponent. So you don't want the minus 4, you don't want the times 2 that's in the front. So obviously you get rid of the minus 4 first by going plus 4 and plus 4. And that's how we get this 4 down here, because 0 plus 4 is 4. Okay, and of course there's no more minus 4. We still need to get rid of the 2 that's out in the front. How do we do that? Divide by 2, divide by 2. So the 2's cancel, and that's why we just end up with 6x minus 3 to the 1/3 power. There it is, 6x minus 3 to the 1/3 power. And over here we got 2 because 4 divided by 2 is 2. And now you want to get rid of the 1/3 power. And how would you do that? Well, remember, a power to a power, you multiply. So 1/3, if you do it to the third power, you're going to multiply the 1/3 times 3. Well, they actually do that right here on the next step. And what you do to one side, you do to the other side. So you go 2 to the third power also. So of course, the 1/3 to the third power, that completely eliminates, because that becomes 3/3, which becomes the power of 1, which means that you don't need to do anything. You just have the 6x minus 3 left over. And 2 to the third, 2 times 2 times 2 is 8. And of course, we add 3, and we get 6x equals 11. The answer is 11/6, which is a fraction. Now, of course, you're supposed to go back and check. Now, it sounds, or it looks like it's going to be difficult to check it because you have a fraction. But after all, you are plugging it in to the x position, and you do have 6 times x right in front of that. And this is a divisor of 6, denominator of 6. So when you multiply the 6 times the 11 over 6, the 6's cancel out, and you end up with a nice, beautiful number, 11. And of course, 11, take away 3, that's 8. That's what they wrote right here. And what do we do first? Multiply or deal with exponents? Deal with exponents, right? So you need to think the third root. Again, the only way you know that the power of 1/3, the power, actually, what am I saying? The only way you know that 8 to the 1/3 actually could turn into an answer is if you know that the 1/3 power is the third root. So the third root of 8 is 2. So that's 2 times 2. and then minus 4, 4 take away 4. They put question marks here to see if they actually do end up equaling 0. Because if they do, that's the double check, right? And of course they do end up being 0, so you're absolutely positive that the correct answer is 11/6. If it wouldn't have worked out, then that would have been an extraneous solution. So looking at this example, you have 3n plus 2 to the 1/3 power plus 1 equals 0. Let's do the work here. You're going to subtract 1. You're going to end up with 3n plus 2 to the 1/3 power equals -1. Now, how do we get rid of a 1/3 power? Anybody? Power of 3. That's right. Because when you multiply the 3 times 1/3, you end up with 3/3. And of course, you're not going to write 3n plus 2 to the 3/3 power or even to the 1 power because you don't need it. It's just, it cancels out. You end up with a nice, beautiful 3n plus 2. But of course, what you do to one side, if you did the 3rd power on the left side, you have to do the 3rd power on the right side. Now that is a -1 to the 3rd power. -1 times -1 is +1 times -1 takes you back to a -1. Now you just solve. So you're going to subtract 2 here, subtract 2 there. You're going to have 3n equals -3, which means n equals -1 when you divide both sides by 3. And if we check our answer right here on the teacher edition, yeah, your answer is -1. So I have to add this on to the video. As I walked around looking at the notes that my students took, this work of art, look at it's my body, okay, was done by this fellow right here. Thanks, Jonathan. Thank you.
Where's your other eye, Jonathan?